All right, so what we're going to do is we're going to take some notes on division, dividing polynomials. This is, oops, polynomial long, or we're going to do long division, but just polynomial division. Okay, and we're going to introduce polynomial division by doing some very normal division, and then we'll talk about polynomials. Okay. So yeah, you're gonna want some paper and a pencil, and you're gonna write this stuff down in your notes. First thing, how do we divide 8 by 4? We're gonna ramp ourselves up here, starting with easy stuff, and ramp our way into polynomial division. These are, I guess, polynomials. They're numbers, right? No variable. And so when we divide 8 by 4, we say, okay, how many pieces of 4 are in 8? How many 4s are in the 8? Well, there are 2 4s in the 8. This is 2. I almost wrote 4. That would have been silly. 2. It's like the opposite of multiplication, right? If we multiply 4 times 2, we get 8. And so we're dividing here, okay? What about bigger numbers? What about 4 into, say, 52? 4 into 52, we want to know how many 4s fit into 52, or what times 4 gives us 52. And that's not too hard to figure out just by thinking of, but I want to work through the long division because we're going to use this process for our polynomial division. 4 into 52, what we do is we say, okay, how many 4s fit into 5? We ignore this 2. We say, okay, how many 4s fit into 5? Well, 1. And then we multiply the 4 times the 1, and we subtract. We're really subtracting 40 from 52, but we don't write the 0 here. And so we subtract, we get 1 left, and then we bring the 2 down, and then we have 12. And now we say, okay, how many 4s divide into 12? If we divide 12 by 4, what do we get? Well, we get 3. 4 times 3 is 12. Subtract, we get 0. There's no remainder. And so 4 into 52. 52 divided by 4 is 13. Okay. You can also think of this problem. Well, let's do another one. And I'm going to write this problem very strangely. Okay. So we want to divide, let's keep doing 4, into 97. Now, I already know a number that goes into 97 really well. Or, I mean, I already know a number close to 97 that 4 goes into really well, and that's 80. What would be less? 17 over 4? Right, so I've split this 97 up into an 80 and a 17. And the reason why I'm writing it this way is going to be confusing initially, and hopefully it'll come together. Sorry, I got a message. I may have made a mistake. So this 17 is really close to another number that can go into 4, that 4 goes into really well. So 80 over 4 plus 16 over 4 plus 1 over 4 left over, right? And so then this would be the tens place, the ones place, and the decimal place. Okay, so 80 over 4 is a 20 plus a 4 plus a quarter. We've got a remainder for this problem. And the reason I'm writing it like this is to make you think of polynomials. It looks kind of like a polynomial. This is not really how we write integers, but it's similar to how we write a polynomial. When we divide 4 into 97, this is not how I would work it out. I don't want you to think, oh, I should do 80 and then I should do 17. I'm just showing you another way to think about it. What we really do is we say, okay, 4 times 2 gives us an 8, 17, 4, that's a 16, and I've got 1 left over, right? So it would be 24 and a quarter. But with polynomials, we have to have these extra terms that 4 goes into, okay? And so when we're dividing polynomials, we're going to use this long division method with the subtraction that we use for normal numbers, but applies to polynomials, okay? So let's do some actual examples, and hopefully this kind of ramped us up, and hopefully this didn't like throw you for a loop too far. If this didn't make sense, it's okay. I don't expect you to do that on any problem. I expect you to just do long division. All right, so we're going to start with a simple one. Oh, I should have left myself more space. Okay. So remember, when we divide variables that have exponents, what we're doing is we're going to subtract. So what times 2x cubed is going to give us an 8x to the 5th? Or when we're dividing 8x to the 5th by this number, what are we left with? Well, 4 times 2 is an 8, right? So this would be a 4. And then x to the 5th minus x cubed is going to leave us with an x squared. Plus 6 divided by 2 is going to give us a 3. A single x, because 4 minus 3 is a single x. And then left here, we have negative 5. Negative 10 divided by 2 is negative 5. X cubed divided by x cubed, no x left over. And then we have this 11, so we'd write plus 11 over the thing we divided by. Now, I did not do the long division steps because everything canceled out, but we will do them in a second. The long division steps would be, okay, when we multiply these two numbers, we get a number and then we subtract. And in this case, we got 0. But for our polynomial long division, we want these two numbers to always cancel to 0. The first things should cancel to 0. Okay. We'll come back to that in a second. But all of these multiply to be, well, okay, so we get 6x to the 4th. That subtracts to 0. We get a minus 5x cubed. That's going to subtract to 0. And then we have the remainder of the 11, because that doesn't get divided by 2x cubed perfectly. okay? So that's dividing by a single term. So we're just dividing each thing in this polynomial by 2x cubed. For polynomial long division, though, this is not really long division. We're just dividing each term, and we're not left with a bunch of remainders. We're going to divide bigger polynomials. Oh, it's fine. Okay, you'll notice I wrote a 0 in here. That's going to become important later. I did not write the setup for this problem like it would normally show up. I will do another one of those, but that 0 is going to be important. You'll notice this polynomial we're dividing has all of the x's. It goes x to the fourth, x cubed, x squared, x, no x. When we're doing division, you need every single term, even if the original polynomial doesn't have it, which is why this 0 exists. This polynomial is 2x to the fourth plus 3x cubed plus 5x minus 1. And so we need the 0x squared to fill in the gap for our division. It's like one of the places here. Okay. So what we need to do is multiply this polynomial to match this first term so that when we subtract them, it cancels out. Right? We're dividing 2x to the fourth by ignore all this stuff and just focus on the x squared. We're dividing 2x to the fourth by the x squared. The other stuff we're going to multiply out and it'll trickle down in the function. Okay, so when we divide 2x to the fourth by x squared, we get 2x squared. And so now I'm going to multiply everything x squared plus x 3x plus 2 times this 2x squared. And so that's going to give me 2x to the fourth. So those first terms match. And then 6x cubed plus a 4x squared. Right, so I multiplied 2x squared times x squared times the 3x and times the 2, and I got this red thing. So we multiplied those together. And now I'm going to subtract. Just like we do in normal long division, right? You multiply, you match the first terms as close as you can, and then you subtract whatever it is, right? So here we're subtracting, and so we're going to subtract all of it. So this turns to 0. 3x cubed, it's going to be minus the 6x cubed, so we get a negative 3x cubed. I'm going to write every other line in black. I'm going to color code this. So this line is going to be in black to match our problem. And then the next line, this next term is going to be a different color. So that's what's happening with the color coding. So it's 3x cubed minus the 6x cubed, 0x squared minus 4x squared, and then I just bring down the rest of the problem. That's our first term. Then our next term is going to be whatever multiplies by x squared plus 3x plus 2 to get this negative 3x cubed. So we're ignoring this part of the polynomial. And we say, okay, how can I make this x squared match this negative 3x cubed? Well, it's a minus a 3 and an x. So I'm going to multiply everything over here by this minus 3x, and I picked negative 3x because that multiplies by x squared to match this thing. So minus 3x cubed minus a 9x squared minus a 6x. And so I'm going to subtract all of this. That'll turn this to a plus, 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 and then we'll simplify down again. So these two things cancel. We get negative 4x squared plus a 9x. So this is going to be a 0 here, just like this was. And so we get 4, so we get a 5x squared. This becomes a minus becomes plus 6, so it's 11x. And then minus a 1. Now, hopefully you notice something. Well, maybe not hopefully, but. So we did these first two things. If I multiply this whole function by these two things, this is what I'm left with. Or, is that right? No, that's not what I mean. If we divide this by this, so far we get these two things. We haven't finished dividing. So the next step is to match, I need another color, this x squared, the first term, to the 5x squared. I don't care about the rest of this, 3x plus 2. That's going to get multiplied out and be included. But we want to match the 5x squared with the x squared. So that gives us a plus 5. So that'll be 5x squared plus 15x plus 10. And so we're going to subtract this whole thing. So when we subtract each of those, it's a 5 minus a 5, so that's a 0. 11 minus 15, so that's minus 4x. And negative 1 minus 10 gives us negative 11. Now, this is a remainder. And the reason I'm going to stop doing my process of making this x squared match this number is now this x squared exponent is bigger than the x here. So what I would do is now we're going to write, okay, plus minus 4x minus 11 divided by the x squared plus the 3x plus the 2. This is the remainder term. This is what was left. Otherwise, we're going to get, like, if we keep going, we could keep going here, but it's going to give us negative exponents, which is what this is. Okay? So when we're doing division for polynomials, we're multiplying to match the first terms, and then we're subtracting down as we go, and we're left with the remainder. So our answer is this stuff in red, green, blue, and the black up here. Okay, and we could always check if we multiply back, do we get what we started with? We're not going to do that on this problem, but you could always check it. Any questions so far? Why did we stop at negative 4x? Okay, yeah. So the reason that we stopped here is because now this number is bigger than this. It's the same reason we stopped at the 1/4 here, right? So when we're doing our remainder for this problem, 4 into 97, we get to 17, we say, okay, 16, that leaves us with the 1. 1 is smaller than 4, so that's my remainder term. Maybe I should do another one of these, like just numerical long division problems. Let's do like, yeah, we're going to do another polynomial one too, but let's do like 13 into, and I'm just going to make this number up, so I'm pretty sure it's not going to divide well. 37, 5, 4, 1. So this is in the thousands, right? I'm probably actually going to run out of room, but that's okay. The method we use for doing this long division is the same process that we do for the polynomial long division. How many times does 13 go into 3? How many times can I get this 1 into this 37, really? It's not 3, because if it was 3, that would make a 39, which is bigger than this number. So this is only 2. It goes here, so we'd say, okay, 2 times 13 gives us a 26. We subtract, and then we bring everything down. So that would be a 1, a 1, a 5, a 4, and a 1, right? So 13 doesn't go into this 11. 13 is going to need to go into this 115 for this next number. So how many times does 13 go into 115? I don't actually know. Should use a calculator. Try to do it off the top of my head. It's 8, I think. Yeah, 8. So we multiply 8 times 13. That gives us 100 and 3 times 8 is 24. 104. Subtract. We're left with an 11, a 4, and a 1, right? We just bring everything down. I didn't mean to do that in green. I should have done that in black color. 1, 1, 4, 1. It's going to be another 8, right? Because 104. If I add another 13 to that, it's going to be bigger than that number. So the next number is an 8 again. And so that gives me 104 here. When I subtract, I'm left with 101, which we can still divide 8 into. 8, 10, wait. Did I do something wrong? Oh no, it's a 13. No wonder I'm going crazy. Sorry. So then the next number would be 7. So this is a 7 here. 7 times 13 is 91. Subtract that, we get 10. 10 is smaller than 13, and so the answer is 2,887 and 10/13. We're using the exact same process for the polynomials, except now instead of a bunch of numbers, you're going to have x's and things in here. Okay? When we get to a smaller number smaller than the thing we're dividing by, smaller than the divisor, 10 smaller than 13, that becomes our remainder fraction. And everything else is just multiplying by 13 to get as close to the number as possible. Okay, so we're using the same methodology here. Multiply, subtract, multiply, subtract, multiply, subtract, until you find your remainder. Okay, So we're going to do another one, except this time it's going to be more polynomials, right? So let's do, so we are going to divide, and here are the numbers, x to the fourth plus 2x squared minus an x plus a 5. We want to divide that by x squared minus an x plus a 1. Now, notice something. Notice this goes x to the fourth, skips x cubed, then x squared, then x, and then 5. So this is what I was talking about before. We need to include the x cubed term. So I'm going to set up my division, x squared minus an x, set up my long division, sorry, plus 1. And we're going to divide that into x to the fourth plus a 0x to the third plus 2x squared minus an x plus a 5. We need this 0x cubed just like we need like the tens place in, if we're dividing 101. We have a 0 here. Those are similar. Like if we're going to divide something by into 101, we still have to account for this empty tens place. All right. So now we just ask, okay, what do I multiply this by to match this x to the fourth? We're trying to match the x squared and the x to the fourth. And the answer is, well, another x squared. And then we're going to multiply all of these things by the x squared to subtract. Just like we did with the 13. We multiplied it by 2, and then we subtracted that from the previous thing. So we get x to the fourth minus an x cubed plus a single x squared, because it's times 1. And we're going to subtract all of this. So x to the fourth minus x to the fourth is 0. 0x cubed plus, right? Minus a minus becomes plus. Becomes a single x cubed. And then 2x squared minus an x squared just becomes a single x squared minus an x plus a 5. So I bring down the rest of the problem. Okay, and then we start our pattern over again. What do we multiply x squared by to match an x cubed? Well, that's a single x. Remember, we're no longer looking at this 0x cubed. We're looking at this x cubed because we had to subtract. So if I multiply all this stuff by an x, I get x cubed minus x squared plus an x. And we're going to subtract all this stuff. And when we subtract, we get 0, x cubed minus x cubed. We get an x squared plus an x squared, so that makes a 2x squared. We get minus an x minus another x, so minus 2x, and then plus 5. And then what do we need to multiply x squared by to get a 2x squared? Well, that's just a 2. So 2x squared minus 2x plus 2. I'm going to subtract all that. And this first thing cancels to 0. This cancels to 0. And then we get a 5 minus 2, so we get just the 3 3 is smaller than x squared, so our remainder over here is plus 3 divided by the thing we were dividing by to make the fraction. So that's our answer. Our answer is x squared plus an x plus a 2 plus, what was it? 3 over x squared minus x plus 1. This is our thing we get when we divide. Any questions so far? I think we're going to have time for one more example. No? Okay, let's do a smaller problem. Well, smaller divisor. Divide x cubed minus x squared minus 2x plus 8 by x minus 1. So we have the thing we're dividing, the numerator, the thing we're dividing by, the divisor or the denominator. And so we're going to set up our long division for our polynomial x minus 1 into x cubed minus x squared minus 2x plus an 8. I'm fairly certain that this doesn't divide evenly, but we'll see. I could be very wrong. Pretty sure it doesn't divide evenly though. So first thing, how do we match x and x cubed? How do we make those the same? Well, we multiply it by an x squared. So then we're going to multiply all of this by x squared. We get an x cubed minus x squared. And then when we subtract, we're going to subtract these. This is going to turn into plus, so it's going to turn into a 0. Right? X squared plus x squared turns into 0. All of that cancels out, which is good because now we only need to compare to this minus 2x, right? Why did I use green? I'm sorry. So we get 0 and 0, and then we bring everything else straight down. And so now we don't need to match to the x squared term. There's nothing there. We just need to match to the negative 2x. And so the way to match to negative 2x, well, you multiply this x by negative 2, and those things will be the same. So we get negative 2x plus a 2. We're going to subtract all of this, which means it's going to turn into addition. Right? Negative 2x plus a 2x turns into 0. 8 minus 2 turns into a 6. 6 is a term, is a smaller than the x here. And so then we put plus 6 divided by x minus 1. And so our answer is x squared minus 2 plus 6 divided by x minus 1. Unless I messed something up, but I don't think I did. Okay, so because this turned into 0, both of these did, we just skip it and go to the next thing. Okay, so when we divide x cubed minus x squared minus 2x plus an 8 by x minus 1, we get this. And there's a remainder here. And so that's polynomial long division.